Welcome to Mrs. Sneller's notes for her double block algebra class. These are the notes for section 10.8 entitled Factoring Cubic Polynomials. And basically what we're going to do today is we're going to completely factor a polynomial. So that means we're going to have to take out a greatest common factor and then look to see if it's a difference of two squares or a trinomial. Or we might also have a polynomial, which has 4 terms. So that's when we're going to do the factoring by grouping. So after we take out our GCF, then we basically want to count the terms to see what type of factoring we do. So our first step is always to take out the GCF. Our second step is if there are 2 terms, it's going to be a difference of 2 squares. Our third step is to do guess and check or the box method for any type of trinomial. So trinomial, remember, tri means 3. That's our third step, so we're going to look for trinomial. And then our fourth step is to do grouping, and that's if we have a polynomial with 4 terms. Okay, so the second and the third and the fourth steps are basically to count the number of terms that we have in our polynomial. Now, worst case scenario, if you cannot factor with any of these other methods, then you have to do the quadratic formula. So the quadratic formula is really like our last step here, the quadratic formula. Okay, so let's take a look at factoring completely. So for example 1, we have F parts to it, so we'll just look at the first 4 here. And we're always going to now look and see if we have a GCF. So for part A, I do. And our GCF can be numerical or variable or both. So it can be a number or a variable or both. So here I can take out a 3 from each term. And I could take out an x squared from each term. I always want to take out the smallest exponent because that's the most amount of variables that this guy has to give. He can only give 2 x's because that's all he has. So it's like asking him to pay $4 when he only has $2 in his wallet. So I'm going to take out a 3 and an x squared. So then 3 divided by 3 is 1. X to the 4th, and if I take out x squared, that'll leave me with x squared. 6 divided by 3 is 2. And if I have x squared and I take out the x squared, then I don't have any x's left. Now, I want to look at the parentheses here. I have 2 terms, so it should be a difference of 2 squares, but it's not even a difference, and 2 is not a perfect square. So I'm done with this one then, because the stuff in the parentheses isn't factorable anymore. So the only thing I could do for that one was, to take out a GCF. And sometimes that's all the factoring that you can do, and that's okay. Okay, for part B again, I have to look for a GCF, and I know I can take out a 4, and I can take out a t to the 1st. So we'll do that. We'll take out a 4t. That leaves me with t squared minus 36. I'm going to look at the stuff in parentheses. There's 2 terms, so that should be a difference of 2 squares. It's a difference this time because they're being subtracted. And t is squared, and 36 is a perfect square. So yeah, this is a difference of 2 squares. So I'll leave the 4t, and then I'll set up my parentheses. So I'll have a t, and a t, and a 6, and a 6, and one will be positive and one will be negative. So for this one, I had to do 2 steps. I had to take out the greatest common factor, and then I had to do a difference of 2 squares. Okay, now for part C, again, I'm going to look for a greatest common factor. And I can take a 2 out of all the numbers. And I can take a y out of every single term, y to the first. So if I take out a 2y from everything, that will leave me with y squared minus 5y minus 6. And now inside my parentheses here, I have a trinomial. So that means I'm going to do guess and check, or the box method. Now I don't have a number in front of the y squared, so that's good. But I still need the factors of 6 that are going to add up to 5. Now remember, this is tricky because the factors of 6 could be 1 and 6 or 2 and 3 because both of them get me to 5. So I really have to pay attention to my signs here when I'm setting up my parentheses. So I need the y and the y. Now I need them to add to a negative 5 but multiply to a negative 6. So if I made the 2 and the 3 both negative, they would add to a negative 5, but if I multiplied them, they would multiply to a positive 6. So the 1 and the 6, if I made the 6 negative, negative 6 plus 1 would be negative 5. And negative 6 times 1 is negative 6. So I'm going to use the 6 and the 1. And I'm going to make the 6 negative and the 1 positive. That way my terms add to the negative 5 and multiply to the negative 6. And then I'm done factoring. So there I had to take out a GCF, and then I had to do guess and check. Okay. For part D, I have 4 terms now. Now, we haven't seen this before. This one's new. Okay, this is our grouping. Now, you do want to check all your terms and see if there's a GCF, but you have to be able to take it out of all of them. So I could take an X out of the first 3, but not the last one. There's a couple that have a Y, but not all of them. There's a couple that have 2's, but not all of them. So it doesn't look like I can take out a GCF. So here's how we do the grouping. We can either group the first 2 terms and the last 2 terms, or we could group every other. I could do first and third and second and fourth. Usually it works best if you just group the first 2 and the last 2. Now, between these first 2, you want to see if there's a greatest common factor. And there is. There's an X. So I'll take that out of just the first 2 terms. And then if I look at my last 2 terms, they also have a GCF. They have a Y. So I'm going to take out that Y from both of them as well. And that also leaves me with an X plus 2. That's good. We want that stuff in parentheses to match. If that doesn't happen, then we either didn't factor right or we don't really have a grouping situation going on. So now the last step is to rewrite this just a little bit. I'm going to take this X and the Y, I'm going to take those greatest common factors, and I'm going to put them in their own parenthesis. And then I just rewrite the stuff that matched in the parentheses one time. Now students like to write the X plus 2 squared because they see 2 of them. But what's really happening here is that we're kind of doing an undistribution property here. I'm undistributing the X to both terms, and I'm undistributing the Y to both terms. So if I was going to FOIL this out, I would take the X times the X plus 2, and then the Y times the X plus 2. So if I rewrote that, I would get this statement back again. But I don't need to write the X plus 2 twice. I just need to write it one time. And that's my final factoring with the grouping method. So let's try that again in part E. Okay. I'm going to group my first 2 terms and my last 2 terms. Now notice that within all 4, there's no single greatest common factor that I could take out. 3 of them have X's, 1 of them doesn't. 2 of them have even numbers, 2 of them have odd numbers. Okay, so in my first two terms here, I could take out an x squared from both of them. So that leaves me with a 2x minus 3. And in my last two terms, I could take out a 2. Now, notice that this first term here is negative. So when that happens, that usually means you want to take out the negative with your greatest common factor. So I'm going to take out a negative 2, which will leave me with a positive 2x minus 3, because a negative 2 times a negative 3 would be a positive 6. Now when I do that, again, the stuff in my parentheses matches. So it was good that I took out that negative. If I hadn't, I would have had a negative 2x and a plus 3. So that would have been a clue that you would have needed to take out the negative with the 2. So now I'm going to rewrite my parentheses. I put the greatest common factors together in one parenthesis. And then I rewrite the stuff that matches, but I just rewrite it one time. And we're done. Okay, now part F. Let's see. There's no greatest common factor. And there's only 3 terms this time, so I don't have to do grouping. I could try and do guess and check. But if I try to do the guess and check, I'm not going to be able to. There are no factors of 3 and 2 where if I put them together in some kind of outer and inner combination, they would add up to 8. It's not possible. So this one is one where we're going to have to do the quadratic formula. Now remember, for the quadratic formula, we had our equation x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. So my first term is the a term, my second term is the b term, my third term is the c term. So you do want to make sure they're in descending order, and for this problem they were already in descending order. So then I have opposite b plus or minus the square root of b squared minus 4 times a times c, so take the negative with the 2, all divided by 2a. So I've done my substitution. Now I just need to simplify. And I'm going to start inside the parentheses there. So I'll have negative 8 plus or minus. This will be 64. And then 4 times 3 is 12. Times 2 is 24. I have a negative times a negative, so that's a positive 24. All over 6. And then I have to add what's inside the radical. So 64 plus 24, that's 88. Now 88 is not a perfect square, so I have to break it down. So I need to find the biggest perfect square that goes into 88. And that's actually going to be 4 and 22. So then the square root of 4 will be 2. And the square root of 22, I don't know what it is. We're just going to leave it. And then my last step is going to be to reduce all those whole numbers. So I'll have negative 4 plus or minus 1 square root 22 over 3. I can reduce all those whole numbers by 2. Remember, you can't reduce the number inside the radical because he's kind of considered like he's in jail. He can't be bothered. He's in solitary confinement. He doesn't get to come to the reduction party. Okay. So looking at these examples, you have 6 really good examples of all the different combinations that you could possibly see in your homework. So use these as a guide, especially Part D and Part E, because those are the new ones with the grouping. And the quadratic formula ones should be a review, but just know that if you can't factor with any other method for a trinomial, try doing the the quadratic formula. Grouping only works when you have 4 terms. Okay, now our last example here is to solve this equation. Now this equation, it's written in increasing order, kind of. So if we're going to factor, we want to rewrite it so that it's in descending order. So I'm going to rewrite it so that the negative w squared comes first, and then the 6w, and then the 27. Now, I can't factor when that lead coefficient's negative, so I'm going to take out that negative. And I don't have any other greatest common factors, so I'm going to take out the -1 like it's the greatest common factor. So that basically just changes all my signs. And now inside the parentheses I have a trinomial, so I'm going to factor with guess and check if I can. I don't have a lead coefficient, so that's just 1. So I need the factors of 27 that are going to add up to 6. So I could have 1 and 27. I could have 3 and 9. And 3 and 9 would get me to a -6. So let's try that. I'll set up my parentheses. I'll have a W and a W, and the 3 and the 9. And the 3 and the 9 will get me to a -6 if the 9 is negative and the 3 is positive. Now notice I brought the -1 down in front of those parentheses. We need to do that. And now to finish solving this, I have to set every little part equal to 0. So the -1 equals 0. Remember, that's not going to make any sense. But I'll do the w plus 3 equals 0, and then the w minus 9 equals 0. So my solutions then will be -3 and 9. So again, if this was a parabola, this is where the parabola would cross the x-axis. Okay, so this is pretty advanced level mathematics here. You're using reorganizing, taking out a greatest common factor, guessing and checking, all of that so that you can solve an equation. So definitely practice these problems. Make sure you show your work, and if you have any questions, come on in and see us before school.